Hello friends, this is Astha Sharma from MTech IT 2K21 batch. Now, this is the paper of IIT's MTech 4th Sem NAD second internal paper. Now, let's start our discussion on this paper. Question 1. Which of the following is an example of Gaussian quadrature formula for numerical integration? Option A. Trapezoidal rule. Option B. Simpson one-third rule. Option C. Simpson's third rule. Option D. Gauss-Legendre quadrature. And the answer is Gauss-Legendre quadrature. Question 2. Which of the following is true regarding the weightage and abscess used in Gaussian quadrature formula? Option A. The weight and abscess are equal in number. Question B. The weight and abscess are not equal in number. Option C. The weights and abscess are the same for all order of the formula. Option D. None of the above. And the correct option is the weight and abscess are not equal in number. Question third. What is the order of accuracy for Simpson's 383? Option A 1, B 2, C 3 and D 4. And the correct option is C 3. Question 4. Which of the following is an example of a composite integration method? Option A. Trapezoidal rule. Option B. Simpson's one-third rule. Option C. Gaussian quadrature formula. Option D. Both A and B. And the correct option is both A and B. What is the drawback of using higher order Newton's Cotes formula for numerical integration? Option A. They are less accurate than lower order formulas. Option B. They require more functions evaluation. Option C. They are not applicable to non-smooth functions. Option D. None of them. And the correct option is they require more function evaluation. Which of the following, question 6, which of the following is true regarding the abscess used in Gaussian quadrature, Gaussian Legendre quadrature? Option A, they are equidistant. Option B, they are non-equidistant. Option C, they are dependent on the order of the formula. And the option D, none of them. And the correct option is they are equidistant. Question 7. Which of the following is an example of an open Newton Cotes formula for numerical integration? Option A. Trapezoidal rule. Option B. Simpson's one-third rule. C. Simpson's three-eighths rule. And D. Both A and B. And the correct option is both B and C. Question 8. What is the forward difference operator? Option A. Approximate approximates the derivative of a function using the values of a function at two neighboring points. Option B. It approximates the derivative of a function using the value of a function at three neighboring points. Option C. It approximates the derivation of the following using the value of a function of four neighbor points. And the option D. None of them. And the correct option is it approximates the derivative of a function using the values of a function at two neighboring points. Question 9. What is the backward difference operator? Option A. It approximates the derivative of a function using the value of a function at two neighboring points. Option B. It approximates the derivative of a function using the value of the function at three neighboring points. Option C. It approximates the derivative of a function using the value of a function at four neighboring points. And option D. None of them. And the correct option is it approximates the derivative of a function using the value of a function at two neighboring points. Question 10. What is the divided difference operator? Options are A. It is used to approximate the derivative of a function at a given point. Option B. It is used to interpolate a function at a given point. Option C. It is used to approximate the derivative of a function using the values of the function at multiple neighboring points. Option D. None of them. And the correct option is C. It is used to approximate the derivative of a function using the value of a function at multiple neighboring points. Question 11. What is the shift operator? Option A. It shifts the value of a function to the left or right. Option B. It approximates the derivative of a function using the values of a function at multiple neighboring points. Option C. It is used to interpolate a function at a given point. And option D. None of them. And the correct option is A. It shifts the values of a function to the left or right. Question 12. What is the order of accuracy for Simpson's one-third rule? Option A 1, B 2, C 3 and D 4. And the correct option is B 2. Question 13. Which of the following numerical integration method is used on the use of forward difference operator? Option A trapezoidal rule, option B Simpson's rule, option C midpoint rule and option D none of them. And the correct option is none of them. 14. Which of the following numerical integration method is based on the use of backward difference operator? Option A, trapezoidal rule. Option B, Simpson's rule. Option C, midpoint rule. And option D, none of them. And the correct option is D, none of them. Question 15. Which of the following numerical integration method is based on the use of central difference operator? Option A, trapezoidal rule. Option B, Simpson's rule. Option C, midpoint rule. And option D, none of them. The correct option is D, none of them. Question 16. Which of the following numerical interpolation formula is based on the use of divided difference operator? Option A, Newton's divided difference formula. Option B, Lagrange interpolation formula. Option C, Hermit's interpolation formula. Option D, none of the above. And the correct option is Newton's divided difference formula. Question 17. Which of the following numerical interpolation formula uses polynomial interpolation? And the options are A. Newton's divided difference formula. Option B. Lagrange interpolation formula. Option C. Hermit's interpolation formula. And option D. None of them. And the correct option is Lagrange interpolation formula. Question 18. Which of the following numerical interpolation formula is used for interpolating a function with both its value and derivative at given? And the options are A. Newton's divided difference formula. Option B. Lagrange interpolation formula. Option C. Hermite interpolation formula. And option D. None of them. And the correct option is C. Hermite's interpolation formula. Question 19. Which of the following is true for numerical integration methods based on higher order polynomials? Option A. They are more accurate than those based on lower order polynomial. Option B. They are less accurate than those based on lower order polynomial. Option C. They are equally accurate on those based on lower order polynomial. And option D. None of them. And the correct option is A. They are more accurate than those based on lower order polynomial. Question 20. Jacobi's method is also known as option A displacement method, option B simultaneous displacement method, option C Simpson's method, option D diagonal method. And the correct option is Simpson's displacement method. Thank you so much.